Good morning and welcome to this Micrographics webinar. Okay, today's topic is all about design accelerators in Inventor Professional. My name is Irshad Hanif. I'm the application engineer in Johannesburg for Micrographics. We will be discussing, or I would like to introduce you rather to design accelerators if you're not familiar with it, and hopefully you can leverage it in your designs going forward. Okay, so our agenda for today, I'm going to tell you the purpose of this webinar. Then we're going to discuss a little bit about design accelerators, basically give you an overview about it. We're going to discuss fasteners, frame generator, power transmissions and springs, and we're going to do, of course, a live demonstration to show you where all of them are living inside of the Inventor menus and how you can leverage them and what options you have available when using them. Okay. So the purpose of this presentation, I basically wanted to introduce your mechanical engineers and your designers to Inventor environments, mainly because I found in industry that many people aren't even aware that they are there. For example, if people wanted to put in screws and bolts, they would usually draw their parts separately, assemble them, and then draw them with the holes. And then every time they need to go and make changes, because perhaps the bolts aren't meeting the strength or fixture standards or requirements that are needed to hold the pieces together, they'd have to go and change the part and the design, and it's a whole lot of work. Not many people are aware that this can be done in one shot using the design accelerator tools. Okay, so basically, to summarize, I would like to introduce new users to the design accelerator. Then I'm going to discuss the tools available, namely what aspects they cover, for example, gears and shafts and bearings and bolts, and you'll see later on that they are nicely categorized by type. Then we're also going to discuss how they differ, because some of them can be used just for placement, or you can use them for placement and calculation. So you can have different requirements. So what I mean by that is if you already know what you want to design, if they've been calculated and engineered, you can simply just go and use those tools to place. But if you want to design it having made no calculations, you can actually calculate first and then give those inputs, those calculation inputs, and have the design tools in Inventor make the correct size of bolts or shafts or gears or whatever you need based on those calculation requirements. Okay, so then we're going to explore some example situations. And lastly, we're going to show you how it can be used in real designs that I've made while working, doing jobs for clients that we have at Micrographics. So let's discuss design accelerators. So the design environment provides a set of added functionality tools for machine design in Inventor Professional. So very important to note that you'll only find this in Inventor Professional. The standard Inventor doesn't have this. This is not so much of a problem now because by default you're going to get Inventor Professional, but I believe some legacy users would have just Inventor, or they had Premium Suite, Ultimate, and all the variations. They might not find it if they do not have Inventor Professional. Okay. So these tools are called design accelerators. Just some terminology there to know what Autodesk calls it in Inventor. It is available in the assembly under the design tab. So you're not going to find it in the part environment, only in the assembly environment. Okay. The design tab you'll find is separated into 4 panels, which is what I was saying earlier on. And if you look on the top at our image there, I've given you a preview of what it's going to look like in the design tab, and you'll see that it's separated into fasten, where you've got bolts and clever spins. You've got frame, where this area is known as frame generator, so you can use sort of a rough sketch of what you want and insert standard beams and tubes. Okay. Then you'll see you have power transmission. So this is for your shafts, gears, pulleys and bearings and stuff like that. Also has an area for cam. And then lastly, you'll see the spring area, which is to make tension and compression springs. And you'll see a little menu there. So those are the four groups that it is separated into. And I've listed them down there. Okay, so let's discuss the first one. We will take a look at Fastener. Fastener will allow you to do bolted connections and clever spins. So that's inserting screws, bolts, and pins. So remember, you can do connections that are through holes where they fit all the way through with maybe a bolt, some washers, and a nut on the other end. Or you can do one where they just have screws, so it doesn't go all the way through, and it gives you the option. So you can see where my mouse is here under type, that's where you will select those, either completely through or just a screw that will be partially joined. Okay. Note that the second option will not have the need to use a nut on the other side, logically, because it doesn't go all the way through. You can place fasteners by hole or surfaces. So what do I mean by that? So you can choose that. Well, actually, to be more accurate, you have a bunch of placement options, and you can do it by the concentric. So even if you don't have a hole placed in there, you can just select the concentric area that you want to place it, and the design accelerator tool will make the holes for you. Okay, then you can also select the surfaces if you do have the hole, and you can select the planes which you want the bolt or screw to be between. Okay. The next point is that you can pull fasteners from the content center. So if you look on the right hand side, you will be able to use whatever bolts, screws, or hexagon head type fasteners you have in your content center. So even if you have drawn up a custom list and you made it a custom content center, you will be able to see it because it'll bring you the same content center menu that you are familiar with. Okay. Furthermore, with these bolts, with the fasten design accelerator, you can calculate strength and fatigue. So you'll notice that there's two tabs next to the design tab where you can base it on a certain strength calculation that you're looking for. So that may be very useful if you have a completely new design and you don't know what bolts to put in, but you do have certain strength or fatigue requirements. Okay. The next design accelerator is under the frame tab, and it's known as frame generator. So what is frame generator? It is a tool that allows you to create a framed structure from simple sketches or a part. So how it works is that it uses an IPT that's comprised of maybe 2D or 3D sketches. It can even be comprised of a solid part, and it will use the edges. It's up to you really, but the idea is that you have some sort of IPT that has lines on it, right? And those edges or 2D or 3D sketches can then be taken into an assembly, and you will use the insert frame command to select those edges or lines and say, I want a certain cross section, or I want a certain beam or tube going along that line. Okay, and there are standard beam types in the library. Okay, so your content center library, and we'll place them accordingly. And you will see you have some options there to modify their orientation, their lengths, and their end conditions. Okay, another interesting thing is once you place these beams all together, you will open up all the grayed out tools here where my mouse is highlighted, and that will allow you to have some end treatment. So in the corners where they meet, you can either have them mitered or maybe put in some end caps depending on what you need. Okay. Lastly, you'll also note that on the end of the frame tab, you will see there's a button there, and I'll hover my mouse over it. I'm not sure if you can see very clearly, but it is called the frame analysis tool. We won't really discuss this at all today. It is beyond the scope of this webinar, but just to know that it is a tool available in there. So once you do make your frame using Frame Generator, you can do a quick analysis to see whether it will deform, buckle, or it's basically a mini FEA analysis. So it's not going to be a full Nastran type of thing, but it is a very basic finite element analysis tool available to you. Okay. The next design accelerator we're going to chat about is the power transmission. Okay, and you'll see in that tab, you'll be able to create shafts, gears, pulleys, bearings, and so on and so forth. So this is ideal when you want to basically create a working model, and having to do everything from scratch can be a bit time consuming. Whereas here, you can just pick in sizes and it will draw your custom shaped gears, your shaft, and also insert your bearing. So you can see in this image here that I put up, everything that's you see that's interacting with each other. So those two gears, those two shafts that hold the gears, sorry, I skipped ahead, my apologies. Right, those two shafts that hold the gears, as well as the bearings, are all inserted from the tab, not manually by placing and constraining from the content center, but using this design accelerator tool under power transmission. So you can see it can all be done in one shot very easily to fit into the housing, which is the orange bit, and therefore you don't need to design anything on your own from scratch. Okay, again, it can pull in bearings and belts and stuff from your content center, and it also has tabs in there that are able to help you calculate your required or the output torque that's going to be generated from your shaft and gear assembly. Okay, and the last thing we're going to be discussing is weldments. Okay, technically, weldments is not a design accelerator, or it's not found in the design tab. It's actually its own thing, but I decided to group it in here just because it's also another tool that I find engineers in industry aren't aware of or familiar with, and they can and should be using it since they do make a lot of welded components. Okay, so you can create new weldments from scratch or convert to weldment. So what do I mean by that is basically you can have a sheet metal or a steel assembly, right? Sort of like the one that I have in the preview here. And it can start off as a general assembly and you can convert it to a weldment. Note that you will not be able to go back to a standard assembly once you've converted it to a weldment. That's just the way Inventor works. Or you can start from scratch making a weldment. So in the example that I'm going to show you, I've started from scratch making a weldment and I've made my assembly with two parts. It's the one you see here in the preview. And I'll show you how to use the weldment tools and you'll see what you can do, how to get the welds automatically placed without having to join these two components. Okay, so you can basically join two parts together without having to actually merge the components. They're still separate components, but these parts will be connected by the welds. Okay, then you can define the type of weld, the length of the weld, and how much of weld you want. And you can also calculate the strength of the weld based on those criteria. Okay, this can also be very powerful if used in conjunction with frame generator. So if you think how time consuming it is to make a frame from scratch, maybe some frame to fit on some sort of trucking system or stuff like that, you would find that you'd have to measure each point manually and then cut off or miter them and then go in and put in where you'd want to weld it in your drawings perhaps. Whereas with this, you can do it all in one shot using frame generator, convert to weldment, and simply insert your welds from there. Okay, so that's all basically what we discussed today. Now let us take a look at a live demonstration of all those tools we discussed And we'll keep on referring to this to say where we are in the discussion. Okay, so I'm just going to bring up my Inventor here, and we're going to start with bolted connections. So if I have this particular assembly here, right, and I wanted to basically put in some sort of screw here to hold this to the bottom plate down here. Now I will just turn off visibility for a while here just to show you what it looks like. So in here there's a plate. Notice there's no holes on this bottom plate here. If I turn this on, there are holes on the top here for where I want to place it, but there's nothing on the bottom. But that's not a problem. So I don't need to go and wreck my brain about drawing those holes and getting those things and then placing my screws in. I can simply go to my design tab and go to bolted connections. And I'm in the design accelerator for bolted connection. You'll see that I'm able to choose how I want to place my fastener here. So for example, I'm going to choose concentric, right? Because I know that, well, these are the two holes that I want to join. So it'll just be around the center of that. So I'm going to choose the starting plane, which is here. That's where the bottom of the screw head will be. I'm going to choose the circular references, which are this, right? And then I'm going to choose the blind start plane. Notice I'm using the blind connection type, not the bolt connection type, and I'll show you why. I'm using the blind connection type because the bolt connection type, remember I said, is a through hole, so it must go all the way through so you can fit a bolt. Let me just show you with a blind connection type. It's now asking me for the blind start plane, which I'm going to say is there. I can pick that one, and you can see that immediately it's going to draw a little bit of where the screw goes, and then that red bit is drawing where it's actually going to cut in and draw my screw hole. So I'm going to make it a little bit larger. I can double click on that and say, let's make it 15 millimeters or 10. 10. I think 15 was too large. There we go. So now we have that bottom end, we have the top end of the screw, and the screw is going to sit on top there. So I have that. I do have another hole, so I can simply go back to my circular references and add that hole into the mix, and there we'll see it gives us a preview of what it's going to draw. And from here we can click to add a fastener. It will take us to our Content Center library. Okay, let us just load that. It does take a while because it is loading the Content Center. Okay, taking mighty long here. Let's just see. Oh. It did show up. I'm going to try that again. Just bear with me. It might be that because we are streaming a live webinar, it's starting to act up, doing a lot of processing at the same time. It's also recording this webinar. So hopefully it works this time. It's usually a lot faster than this. So it shouldn't take too long. There we go. So I will say that I want to put in perhaps that type of screw. And you'll see that it's starting to place that based on the settings that I put in. Now I can go in here and I can change these the way I want. So I remember I can double click and I can enter my own length, or can leave it with the standard length so I don't go and order unnecessary parts that I don't need. Okay. And once I'm done with that, I'm going to click OK. And you'll see it'll calculate all of these things, making sure that it's placing it in the right place and also cutting out the holes for me. So you can see I've placed my screw in there. And if I hide the visibility of that, and perhaps that as well, we can see that it's made the hole for us based on our requirements with the correct threading applied. So you don't always need to design your parts fully if you know that you're going to be putting some sort of fixtures or fasteners in there, because the design accelerators can help you with that. Okay. I'm just going to go back by undoing that a few times. Right, I'm going to enable that again. I just want to let you know about the other types of bolt connections, which I said was if I'm using concentric, right, the start play and the end plane there. So I'm going to go here and I'm going to select the termination plane there. So now if I'm using the through hole type, you'll see that I'll be able to choose a bolt type connection and insert washers. And let me see if that works. Right. So now I'll be able to search from the bolt category. For example, if I choose that one, right, it will allow me to extend beyond that, and I can add in perhaps a washer on the top end and a washer on the bottom end, and perhaps a nut on the termination end. So let's just show us a preview of what that's going to look like. You'll see that is giving us a preview of the washer that it's inserted. I can do the same on the other end by clicking that, and the last one will be for the nut on the end here. So you can see it comes after the drill hole. What exactly do you want? And I can choose and lastly, I will select to put in a end fixture or an end fastener, such as a nut. I'm just going to choose that type of locking nut, and you will see, okay, perhaps I've got to extend that, and I'll just click another circular reference to make sure it goes. All of that goes on the other side as well. and you'll see it'll do that there as well. And when I'm done, I can click OK. It will calculate all of those, pull out all the parts from the content center, as well as drill the holes for me. And we have that. So you can see I've actually selected the wrong starting plane there, but that was my mistake. But the idea is that you can fix these two with nuts and washers all in one go. Okay, so that was bolted connections. Let's go back to our PowerPoint. We're going to now look at frame generator. Okay. So if I look at, I've got a blank assembly here. I should rather just remove that. Right. Frame generator works by using this in the design tab, but currently it is blanked out. And if I go into insert frame, you're not going to be able to do much. So why would that be? Well, simply because to start with anything, like I said in the presentation earlier on, you need to have some sort of IPT here that has either edges or sketches or lines. So what I'm going to do is in my assembly mode, I'm simply going to create a part. I can also just go in and import a part, but I'm going to create it since I don't have anything here, and I'm just going to call it skeleton. It's going to use standard IPT, and I'm just going to place it anywhere in there. So now I'm making this part, and like I said, all we need to do is draw some sort of sketch or extrude something. All right? So I'm going to start with my rectangle from here. I'm going to make it, well, let's say it's got to be fairly large to be a frame. So I'm going to say maybe 1,500 millimeters by 2,200 millimeters. So 2 meters by 1.5 meters, roughly. Okay, so I'm going to say finish sketch. Now, as is, since this is just a sketch, these are lines. If I return, I can probably save this and use this in my frame generator. So when I return, I can actually go to my design tab and say insert frame and actually use these lines for my frame generator. Can you see? So it'll ask me to choose what I want to place in here, but just to show you for illustration purposes, I'll go back in here and I'll edit, right? And I will extrude this to get 3 dimensions. I can leave it like this as a solid, but I prefer to just make it as a skeleton model because I'm only going to be using these lines for the edges, nothing else. I don't think I'm going to put anything on the top or bottom, but you can leave it as a solid. It will still work if it recognizes the edges. So I'm going to say, let's make it 1025. Yep. So that's good. And I'm going to go back. Now if I go to insert frame in the assembly, I can still select these edges. So that's great. So I'm going to choose a standard beam top. I can choose I-beams or channels. I'm going to choose square rectangular tubing, and I'll make it say 50 by 30 by 2. Okay, so I'm going to choose there, there. So you can see how easily that wherever I'm clicking, it's just placing in the standard cross section that I've selected. In fact, if I change it to make something square rectangular tube, so let us look for something like well, I suppose we can choose from a family of square tubes first, and then we'll see we have standard sizes only, so 40 by 40, 50 by 50. Let's make it something larger so we can work with it better. So let's go 70 by 70 by 2.5, and that looks a little bit better. Okay, I'm going to do one last one there. Now notice as I'm using the frame generated design accelerator tool, all these are still grayed out because I haven't placed it yet. And also notice that the end conditions are a bit messy at the moment. It's just placing along the length of the line that we specified. I also have tools here to modify that. So I can say, how do I want to place it? So for example, do I want to place these with an offset of 15 in the A direction, or like this? So if that's, you can see that I know that this was 70, so 35 offset will be half the length and it'll be on the edge of the line. Or I can say negative 35. So it goes on the edge of the line on the outside, and you'll see it merges that way. So you can play around with it and arrange them the way you want it. I'm going to just say okay as is, just to show you how we can get a simple frame done. You'll see that it says, okay, this is the summary of all the frames it's going to create for me. Great, brilliant. Okay, so far so good. Now we'll see that our, like I said, our end conditions are a bit messy. I've moved things about where I shouldn't have. So just for illustration, I'll do that again. But I just want to do the ends on, and I'm going to remove any sort of offset that I had placed previously. I just want to get something more clear to show you how I can now neaten that up after placing them. Okay, so now you'll see that I was waiting for that. Um, I was about to show you that these tools had now been enabled, but they were still being generated and allowing us. Now that these tools are enabled, I can actually go in and neaten the end conditions here. So let us take a look at what I can do. I can do stuff like trim and extend, miter, notch, etc. Now, this is not a complete lesson on how to use these, but I can just show you as a preview. I will link some better webinars that we did earlier that are completely focused on frame generator. But basically, you can see that I can choose two beams that I want, or multiple beams that I want rather, and it will neaten them out for me by applying the type of command that I want. For example, miter or notch. In this case, I'm using the miter, and you can see I can define exactly how much of a gap I want to leave between them. But it's as easy as going and selecting the beams that you placed and saying I want to miter all four of these frame members, and just like that, you've got it. From there, you can say, right, I want to now trim and extend the rest of the members, because if you can see here, these ones sort of eat into there because of the way we placed them initially. So we can say, all right, I want to look at that face, right? And the frame members that I want to trim are that one, that one, that one, and that one. So you'll see even before you even click OK, you can see that a preview of how it's trimmed it to that face there, and we are good to go. You can also click in multiple faces. So for example, it will trim by 2 faces. So on the top and the bottom. I know, I apologize, that is not the case. That is something that would be nice for the idea station at Autodesk if they can trim by multiple faces, but it's not a problem. We can simply click the plus and do the same command again with a different face. Okay, I'm not going to do that, but I think we've basically covered the very gist of the design accelerator for frame generator. So let's go back to our slideshow. And now we're going to discuss power transmission and springs. So let us look at power transmission. We have, for example, let's just take a completely blank assembly. Now, you can see this engine set up here. I wanted to connect these two separate components that I got to put in a larger assembly, which is here if you want to see it. It's basically this. Right? I wanted to put this sort of engine here and connect some of the power transmission components. So in order to do things like draw shafts, I can simply go to my design tab and I can say, right, I want to insert a shaft between certain points. Okay. And you'll see that it will create, I can specify where this shaft wants to start. Okay, I've already drawn that there, but I'm just going to draw it out in space to show you what I'm doing. And I can say, right, I want to place my shaft there. And you'll see that I'm now able to go in and select each section here. So it allows me to draw a shaft that's made up of multiple sections, which will obviously be turned and worked by a machinist to get the shape. And I can say, I want to specify, for example, that must be a cone type. And I can define the length of it. So you can see here. And you'll notice that the cone here as well, I can say the cone type, right? Or I can delete out members here. And I can enter the length from standard lengths, or I can simply double click and define these lengths here. So I can put 85 or whatever it is I want. So you can see how you can make a standard shaft, right? And you can see it's quite easy to change stuff. So if I wanted to double click on this, I can say, what? Oh, that's starting at 85, or I can change the length depending on how I want it. It also gives you a little diagram there of diameter 1 and diameter 2, right? And you can have features and fillets. So for example, you can say that, hold on, this end I want to have maybe chamfer features on the ends between the transition of the change. So I can have those features in there and you'll see it puts them in for me. So very easy to make a shaft. And very easy then to place that command into my assembly where I want it. Right? I'm obviously not going to place it in here just yet, because I mean I don't have a place for it. I normally would place it, for example, there somewhere. But know that once it's in your assembly, you can then go in and add your bearings or V-belts or pulleys or what have you. So you can say, I want to choose the cylindrical face from there, and you can see that it's now going to place some bearing out there for me. And you can say, I want to maybe start plane is there, and you can flip either on outside or inside. And then you can say maybe minimum required outside diameter or whatever have you, or you can go by calculation, and you'll see that you have an entire bearing maker calculation depending on the torque or axial or radial load that's being applied on this design. So you can calculate from there all this. I'm just going to go with my basic. I'm going to say from, you can say, let's say 50 to let's just make that jump. So we'll say it's going to be placed on there. Now you can also just search for angular contact bearings. Okay. Or you can just, let's leave all of this. Let's just search for everything. We won't put in, this is basically a filter to filter out certain sizes. So you can say, okay, let's choose that size. Okay. Then we can also select another cylindrical face. Say, okay. So now we've added our bearing in here. We can do the same to the other side. And we can add in maybe gears or spurs, or depending on what, in much the same way. And we can build up our component. Also, each one will have a calculation tab. So if you're not sure what size of gear you need, what size of shaft you need, or what size of bearing, you can always calculate from your requirements, and it will retrieve the best gear size for you. Okay. This also helps so that you don't have to go and guess or estimate and risk failure of your system. It is very useful. I'm not going to go in. Like I said, this isn't a very comprehensive lesson, but rather just a quick overview to show you the tools. The springs will work in very much the same way. Okay, so we are running short on time, so we're just going to go back and we're going to look at the last topic there, which is weldments. So now we're on weldments, and let us take a look at weldments. Okay, so I have a, let's look at this. So I've created a assembly, which is basically these two parts. Okay, it's just two pieces joined perpendicular, right? You can create if I go to file, I can create a new, if I go to new, right? Let me just click, oops, the window went on the next side. Remember, I do have when I'm creating new, I have the option to create a standard assembly, or I can create a weldment from scratch. So you can start by drawing this as a standard assembly and then converting to weldment in very much the same way that you do with your sheet metal. Okay, but I would advise that you always start by creating a weldment because it saves you a couple of steps. Okay, but it's the same thing. I've started and I've created a weldment, so I went to file new and I've created a weldment and I've built my two pieces in here. I built the base and I built the cross section upright here. And if I wanted to say that these two are now joined by a weld, I can simply go to my weld tab, which you'll only find once you've converted this to weldment. And I can say, right, now I'm going to enter the entering welds tab. You'll see that it takes me to a different tab where I've got the return button. And I can say, I want to simply add, for example, a fillet weld between the two faces. So it's asking me to select the two faces. I'm going to start by selecting the horizontal face. And then I'm going to select my second face, which is here. And you'll see that immediately it inserts a weld across there. Right? I can also select multiple faces so that it forces it to put welds on both sides as long as they're part of the second selection of the faces that you want. Okay, I can define the size of the weld. So I say let's make it 10. So that's a really thick, strong one. I can define how the weld appears, what type of weld, so that you can label it later on in your drawings. And I can also define maybe intermittency. So if you just want to do little strip welds or bead welds, you can say, let's say select 5. And we'll start 2. And the number of welds is 3. And this here is, so it gives you a little diagram. So 5 is the length of each bead weld. Then the second one is the gap between them. And the number is basically how many you want. So you can see it's made them here, but I'm just going to say, I think the length there was 150. So I'm going to say, let's make them 25. And the number is, so you can see stuff like that. And it made little bead welds across there. Or rather, what I can do is say 3 welds and okay. So as long as you got your math right, or depending on what you want to do, you can just say make 3 bead welds across that length, and we have it done like so. Okay, so you also have the option to do groove welds. So you'll see a little diagram of one there. Again, this is not a complete lesson on welds, just to show you that it is possible, and you can create 2 separate parts without having to make a fillet between them, but you can actually create a weldment. Once I'm done, I can click return, and you'll see that now my assembly 2, which also note has a different icon because it is a weldment, has these welds attached to it, and you'll see that it has these bead welds across that pattern. So you can anytime go in and edit that as a weldment feature. So the components don't ever change, but if you want to change the way you welded them, you can always go back and do that. All right, so that brings us to the end of our webinar. We've discussed bolted connections, the frame generator, power transmission and springs, weldments, and that was basically the topics for this webinar. We're going to move on to our Q&A session. So if you guys have any questions you would like to ask, if you haven't asked it on the chat already, you can ask, or you're welcome to contact me on my details up on the screen right now. You're welcome to phone into Micrographics and speak to any one of my colleagues also. They'll be able to assist you with these. And yeah, we're just going to give you a few minutes to round up. And if there are no questions, thank you for joining us. And that is the end of this webinar.